Excuse me. Okay, so we're going to prove the law of cosines. So what the law of cosines says is that for triangle ABC, right, we have ABC, that little a squared, is equal to little b squared plus little c squared minus 2 times b times c times the cosine of a. All right, and then of course we repeat that for each of the other sides, switching out, you know, we put a, plug a in everywhere we see b, right, and then b, you know, goes in everywhere we see a, and vice versa. So, you know, basically from any of the angles we can do it, is what it says. So now we're going to prove it. So we're going to start by, you know, like we did before, we're going to drop. Now this problem is useful. Let me tell you when it's useful, sorry. It's useful, the law of sines, as you remember, I said there are, you have 2 sides and 2 angles. And so as long as you have 3 out of the 4, okay, and that is our law of sines, right? So that would be, this is law of sines. I don't want to get too confused here, but if I know, like say 2 sides and an angle, so side, side, angle, then I can solve a problem using the law of sines. If I know, let's say angle, angle, side, then I can use the law of sides. But unfortunately, and these have to be opposite, they're pairs that are opposite each other. I can't do it for angle, side, angle. So because I've got to have at least one ratio. This is ratios here. So if I only knew B, C, and A, I don't have an angle opposite B, I don't have an angle opposite A, and I don't have a side opposite C, so I can't be writing those ratios. So the law of cosines is different. Law of cosines is useful when we want to solve a triangle and we know one side, another angle, and another side. So if I know these, I can solve for the third side, and then we can work on, you know, using the rest of our information to solve for angles. So let's do it exactly and just see how it is. So just like before, what we would do is we'd think, you know, this is going to involve triangles, right triangles at some point, because we're going to do some ratio stuff. We're going to do some trig ratio stuff. So we drop our height or altitude there and call it h, right? And then we say, well, how long is if we just want to deal with just this triangle, well, it is x units. We don't know. We don't know how long this segment here is, right? We only know that the whole thing here is c units. So if this much is x, then how much would this be? Well, it would be c minus x, right? It's all of c taking away that part. Right? If I have all of c and I take away x, I'm left with c minus x. So now I have some actual triangles I can work with, and it's presumed I'm going to know some of these things. Let's go ahead and write our cosine of A. If I said, what is my cosine of A? We know that's a ratio, which is this side here from A. This is the adjacent side over the hypotenuse. So we're going to put x over b. So can we solve for x here? Sure. X is equal to b times the cosine of A. So that's what we know about x. All right. Now let's stop there for a minute and let's just think about. Let's solve this triangle here. What do we know about this triangle here? Well, if we use Pythagorean theorem, we would also know that x squared plus h squared is equal to b squared. That's kind of good to know too. All right, now let's look at the other triangle. And if this was point D right here where we drop, we call this triangle CDB. Okay, so let's look at triangle CDB. So first of all, let's use the Pythagorean theorem. And you know what I'm going to do? I'm going to cross this out, because it really goes to this triangle, so I'm going to write it over here. x squared plus h squared equals b squared. That's x squared plus h squared equals b squared. Let's start with the Pythagorean theorem here. So what do we know? Well, we know leg squared, that's h squared for this triangle, right? Plus c minus x squared, right? That's this value in here. C minus x squared equals this a squared, right? You see where that comes from? Equals a squared. So now what we're going to do is we're going to do a little bit of what you might remember as foiling if you learned it that way, or maybe you learned expanding. And I'm going to, if you FOIL that out, I'm going to actually just use my calculator to show you how to expand on the calculator in case you've never done that before. There's algebra and there's expand. And I just take an expand, and I'm going to put this because I know this is a binomial, and this means I have two binomials being multiplied, so I've got to do my foiling here is really what I got to do. But what I'm going to do is I'm going to just put another parentheses. I'm going to put everything right here in, so that is c minus x, and close my parentheses and square it, and hit enter. And I can see that if I were to FOIL it out, and you're welcome to FOIL it out if you prefer, but this right here turns into, this part alone turns into x squared minus 2cx plus c squared. And that's equal to a squared when added to h squared, right? Okay. So now, let's think about this. See this part here, x squared plus h squared? This part right here. This part, we know that x squared plus h squared is equal to b squared. Remember, we already solved what x squared plus h squared is. So we're going to put this as b squared minus 2cx plus c squared equals a squared. Wow, that's not too bad, right? And now let's see. So now we're going to just let's just rewrite this a little bit. I'm going to put the a squared here first. So we go a squared is equal to, so I'm just putting that on the left side. I'm going to start with b squared here, right? Plus c squared minus 2 times c times x. That's this part in here. So all I've done is just kind of rearranged my terms there. So now I have minus 2 times c times x, but I have a solution for x. Remember, I solved for x. Here's x. Here's b times cosine of a. B times cosine of a. So I'm going to substitute in for x this value right here. Okay? So here we go again. A squared equals b squared plus c squared minus 2 times c times b times the cosine of a. All right, that was the cosine of a there, right? So a squared equals b squared plus c squared minus 2cb times the cosine of a. Now let's think what I told you that I could use this for. I could use this if I knew an angle and I knew two sides. So here, let's go through this again. Ready? In this case, if I know this angle here, A, right? And then I knew side B and side C, so I know side, angle, side. So if I knew B, A, C, little b, big A, little c, I could plug them in here, and guess what? I could solve for little a. Because I don't have anything else in there that's unknown. See, I don't have anything that's unknown. So now we're going to actually try and do a problem like this, okay? So we'll go to GeoGebra, and we're going to construct a polygon. So I'll try to make it look a little bit like the polygon or the triangle we were just looking at. We don't know what x is. what we are going to know is this side, and that angle. So let's measure those sides. This side is going to be 3.31. That one's 8.53. And now I'm going to measure my angle. So here we go. I'm going to go like this, click, click, click. And I can see my angle is 27.71. So now let's put in some information here. Remember our law of cosines. Now the law of cosines is kind of funny. It says A squared is equal to B squared plus C squared minus 2CB or BC times the cosine of A. Okay, so what is A squared? Well, that's the unknown side actually. Okay, and this, we're going to call this angle A in this case, right? So I'm trying to solve this opposite side. So I put this is basically my known side right here, okay? So my known angle, okay? And then as B and C would be my sides next to my angle. So I'm going to say, gosh, I don't know what A squared is, but I know that B squared means 3.31 squared, right? And I know that C squared means 8.53 squared, right? And I know that minus 2 times 3.31 times 8.53 would be, and then times, the cosine, times the cosine of 27.71. Okay? Now, I'm going to set that into my calculator. I'm going to pause this so you can see it. Okay, so again, here we had A squared equals, there's B squared. So that's again, this is the unknown side for me right now. So I'm going to take my known side on the left, which I called 3.31, right, which was this side right here, and called that B, so that would be 3.31 right there, and square it, plus the other known side, right, which was over here, which in this case I could call C, little c. I got these numbers backwards. We should have measured this side, and tried to solve for the far one. But you get what I'm talking about. One side, and we know the angle in between it. So anyway, I put that 8.53, the other side, the known side in there, and squared it. And I put minus 2 times one side times the other side times the cosine of the angle, right? So that's what we've got written up here. And then all I have to do is enter. And I have 33.7246. Well, you might be saying, gosh, this isn't 33 units long. If that's only 8, this can't be. Don't forget that this 33.7246, that is in this problem what A squared is equal to. So we could put it down like this and say A squared is equal to, it was 33.7246. That's not a good answer, right? So we have to take the square root of both sides, and A is equal to the square root of 33.7246, okay? And we can use our calculator again for that. So we're going to do square root of that value. And actually, you can see that's kind of nice. When I copy and paste it down, it puts a lot more out there, so it's going to be a lot more accurate. And I get 5.80729. So this side should measure 5.80729. So let's go ahead and take a measurement of that side and confirm. 5.81, which is 5.80 rounded, right, up to 5.81. So we did it. We solved this side. Now, you could use the law of sines from here on out, because we can write a ratio, right? The sine of this over 5.81 is equal to the sine of x over 8.53 is equal to the sine of y, this angle over here, over 3.31. And you could solve the entire problem that way.